Okay, this is supposed to be a take-home study question. So what I think you should do right now is you should pause the video, try to work it out. And since we're all bobcats here, we could pause. Okay, pause the video and work on the problem yourself. And you can work on the problem referencing the last video we did. There are also solutions online in the notes. Pause. I've got a 3.50 molar solution. Now, molar is molarity, and hopefully you remember what molarity is, moles of solute per liter of solution. It's an aqueous solution. That means that our solvent is H2O of sodium sulfate. This is our solute, and so we're going to need a formula for that. So our formula is Na2SO4. All right, we need 2 + 1 sodium cations for 1 - 2 sulfate anion, and it has a density of 1.21 grams per milliliter, which means we're going to have to convert from volume to mass, and using the density as our conversion factor. And what is the molality of the solution? So let's remember what our units are. I'll try to be neat. It's not easy for me. Broken every finger I have. Molality is moles of our solute, which is Na2SO4 per kilogram of solvent, and our solvent is water. The molarity is, and this is just the definition, and I'll go ahead and I'll use the 3.50 molar. So that's me. What this means is I have 3.50 moles of Na2SO4 in every 1 liter of solution. And it's important to remember that the solution consists of the solute, which is the sodium sulfate, plus the solvent, which is the water. And if we're going to convert this unit of concentration to this unit of concentration, you can see that we're going to need to remove the solute. And then once we've got a mass for our solvent water, we can just convert it to kilograms, from grams to kilograms. So we have to subtract the solute out of here. Okay, so first things first. Well, we've already got 3.50 moles of our sodium sulfate, so we'll be able to use that in our final calculation. But what we need to know is, well, how many grams of Na2SO4 are there? And the way we do that is we take 3.50 moles of Na2SO4 and we convert it to grams. So we know that 1 mole of Na2SO4 is equal to 2 moles of sodium cation. Each of those weigh 22.98. Then there is 1 mole of sulfur, which is 32.07 grams per mole, and 4 times 16 grams per mole for the oxygen. And when we do that, we get 142.05 grams for every 1 mole of sodium sulfate. That is somehow a 1. Oh gosh, just making it worse. At any rate, we can go ahead and convert this to grams. So let's do that. When I multiply and divide across, moles of sodium sulfate will cancel, and I'll wind up with 497, I think that's good enough, grams of Na2SO4. The next thing I need to do is I need to convert liters of the solution to grams of the solution. Once I've done that, my strategy is to subtract the solute, the grams of sodium sulfate, from the grams of solution, and then convert to kilograms. So here we go. So that's going to be X grams of solution, which is going to be equal to 1 liter of solution. I'll convert liters to milliliters, and there are 1,000 milliliters per liter. And then in every 1 milliliter, there are 1.21 grams. So 1.21 grams. All right, so that's all I need. My liters will cancel, my milliliters will cancel, and really I'm just multiplying 1,000 times 1.21, which is 1,210 grams of solution. So real quickly, I'm going to go ahead and just subtract 497 grams of my solute. And you remember my solute is the sodium sulfate, and I'll get 1210 minus 497. That gives me 713 grams of solution. 713 grams of solution. Right here, I'm going to convert it from grams to kilograms by dividing by 1,000. The grams will cancel, and all I'm doing is moving that decimal place 3 places to the left. So now I can go ahead and calculate my solution molality, and that's going to be X moles of Na2SO4 divided by kilograms of water, which is my solvent. And that's going to be 3.50 moles. We are talking about a solution. That is, the concentration hasn't changed. It's just being expressed in a different set of values. So the 3.5 moles, still true. And then we've got 0.713 kilograms. 3.5 divided by 0.713, and I wind up with 4.91 molal. So we've said this before. The molality and the molarity will be pretty close for dilute solutions. You'll have a little bit larger number for molality typically, and that's because you've removed the solute from the denominator, giving you a smaller value, which is going to result in a larger number for the molality than you have for the molarity. And they'll be pretty close to each other. Usually somewhere between 10 and 20% of each other. All right? Now, here's what I recommend. I recommend that you work this problem in the forward direction, going from molarity to molality, just as the problem is written. You'll get 4.91 molal, and then start with 4.91 molal and convert it back to molarity. If you go back and forth 2 or 3 times, you'll get a procedure that you're comfortable with. You can keep it in your head, and it'll be an easy conversion factor in the future. Okay?